Hi, Sarah. Hi, Sarah. Can you hear me?
How are you guys doing? Can you hear?
Can you hear us? Can you hear me? Can you hear me? Can you hear me, Sarah? Can you hear me? Can you hear me? Sarah? Sarah? Hello?
I can't hear you very well. Can you hear me? I can't hear you. Almost. Ah.
You hear me now?
There.
For my.
Are you in a different room, Chun, than you were last week?
Does it look different? It looks different? It looks different? Yeah.
Maybe you guys just moved a whiteboard over or something.
Oh, yeah. We're going to move. I'll move that over. Sarah, what else are you working on?
A few different things.
I'm sorry?
A few different things.
Yeah.
One of the things is a new center called the Center for Inquiry and Equity in Mathematics.
Huh.
It is a center for university faculty in education to come together and work on mathematics in a little bit different style than this. It's mostly like they have to generate their own questions from their own teaching. And then they work on them with mathematicians from a network that a friend of mine runs, and that network of mathematicians is it's completely mathematicians from underrepresented groups. Most of them are Black mathematicians. And by the way, there are very, very, very few Black mathematicians in the country. So like I never had any professors who were Black when I was an undergrad or in graduate school. So then the education faculty also connect the mathematicians with their pre-service teachers. And they do math together with the idea that pre-service teachers, before they even get started on their profession, get a different vision of what math is and who does it. So that's a big part of my work right now.
No, we can.
I didn't just do that. For my math.
Hi, Casey.
Hi. I didn't go to work today.
You what?
I didn't go to work. So,
You didn't go to work?
hopefully you can hook me up with some paper.
Oh, it's like, yeah.
Jen's down the hall. She's doing another meeting.
I'm trying to have this random paper that's in my closet. So yes, yes.
She's down the hall.
Johnson coming. There's like a little like flower there. There's so much random paper in my closet. I'm like, I'm just gonna start using it. Yeah, I have that.
Yeah, he asked me to. And he's good.
Yeah.
He's doing a lot of vacation things, so
Yeah.
I was just wondering if any vacational example.
I think Oklahoma is coming today, but just in case,
Yeah, because I know we definitely did some things.
should we start, you guys?
Call and like.
Yeah.
You, Yan, can you guys hear? Should we go ahead and get started on the opener? I think Oklahoma is coming, but since I'm not sure, let's just start.
Yeah.
Okay, so just do the calculations of the opener.
Yeah.
And Ton, did you guys hear that too? Just go ahead and get started on the opener.
Yeah.
Great.
Right here.
Three plus four.
Did everyone get an opener?
I get the one.
Somebody else's pencil.
And then I forgot. You know, smoke. Where
You'll get, yeah.
you get negative, I swear. And you get negative, positive.
Yeah. So V9 plus 25.
How I interpret where finding the norm of.
I think we find the normal. Oh, sorry. No, we have the normal original. Oh, oops.
So 2 plus
We're having the norm 2 plus I. Oh, oops.
That was the norm. It's the norm.
Just need the redirection. I tell my kids as well. So it would be 1. No, 2.
I was going to talk with you.
With that negative, be positive.
Positive, so it's 5. Yeah.
Right.
It costs to
Split it out. last
I'm
column?
just gonna,
Wait, how did you do the filters?
No, they.
it's a little confusing me when it says square, because we didn't square it last time.
That's what I thought.
We just did
did
the conjugate, but maybe it's both somewhere. I don't know.
It's both, Ton. It's both.
You know, listen.
like what we did
She
with
said,
the.
Yesterday, yeah.
there's some footsteps.
Yeah.
Oh, of the original. Got it. So where does this go? Where does the 4 go?
It gets added. This is I squared is what?
What did you guys decide or what it meant by the original number?
I'm doing both. I'm getting 2 answers for each one. I just square it, 2 plus I squared, figure that out, and then do 2 plus I times its conjugate, and then figure that out. So I'm getting like 2 answers for each.
Good.
So you did.
Yep, that's good. I don't know who said that, but that's good. Was that Ariel?
Yeah.
Yeah, that's right.
So you do
Yeah.
3 plus I squared.
Mhm.
Solve
Oh yeah, because you.
that answer.
I get 8 plus 6 I.
Looks like like the number looks like they switch.
Because that's -1. So that would be
Is I -1 in this situation?
I squared.
I squared.
We've got an I squared right here.
Is it? Wait, in general?
I squared.
So
Wait, I square.
is
Hold on, this is
the
new to me. I square is -1 always.
What's I?
I thought I was any imaginary number.
I is
You told me that I was.
For the other problem set, I don't know if
I is always
Mhm.
the square root of
Shut up.
negative.
Wait. Okay, wait.
That's
Flag
new.
that
Okay.
to talk about as a whole group. Okay, really, that's really important. Can you, Ariel, can you write that down on the
Yeah, I wrote it down.
board? By the way, I think last week you were actually working with I squared being -1. I remember your calculations. But
Yes.
but a lot of things would work if you just treated I as a variable too.
Gotcha. Okay, I thought I was like any imaginary number. Didn't realize it was square root of -1 every single time you see it. So that makes sense. Okay.
So now we're
I have-
finding the conjugate
I know it stays close to the
plus I and 3 plus 4I. Right? This one?
So for each
You're finding the
single
conjugate of both.
one- So for each one, you're doing.
This is what I don't
You're
understand.
doing this. You're finding for 2 plus I. You're finding that squared. You get an answer.
Right, 3 plus
And
4I.
then you take this, multiply it by its conjugate, 2 minus I.
Mhm.
You get a different answer. Then you go to the next one.
But I'm not also finding the conjugate of what I got squaring 2 plus I.
I wasn't.
That's,
Wait, you can't find a conjugate?
no, I'm,
She's saying,
Sorry.
she's saying if you, when you get this, are you doing this?
Yeah, the numbers are.
I don't quite see it.
Oh.
which is no.
Yeah.
Mhm.
They got these guys in New York. Yeah.
Hmm.
Seeing like no real pattern. No first opposed to, but
Like between the. Wait, hold on. Wait. I think I see something. A 3, 4, 5, 8, 6, 8.
16. Oh, I see. 5, 12, 13.
Yeah. The,
8, 15, 17. Oh, I see it now. Yeah. So 20, 21, 29 is the triple.
yeah.
Yeah.
Yeah. I didn't-
Sorry. Oh, sorry. What's
So
the
this is the
squares?
square and this is the norm.
Ooh, did I do this right? 5. Did I? Did you get 21 plus 21? That one for some reason doesn't.
Okay, did I make a mistake?
No, I did the same thing. I got the same answer. I mean, it's 20 squared,
Jeez.
right? Twenty squared plus 21 squared is 840. Why did it do? Oh, because I can't type. No, okay.
So what? Oh,
Yeah, I just mistyped. So yeah, there's something. These are
Sarah, is there a Google Sheet for us to like log in?
I think it would be good to stick to, I really like that 3, 4, and 5 sheet.
Oh, okay.
So let's use the same one because I think it's handy to have those three sheets of weeks 1, 2, and 3 accessible rather than having tons and tons of sheets.
Yeah.
So if what you did last time with logging, what you were doing at any given time is perfect. You can, I don't know if you noticed, I just added 3, 4, and 5 to the sheet. I'll put the link in a chat.
Oh, okay. Thank you.
Because the other thing is, I don't know about you guys, but every time I open up a new sheet, everything freezes. So having just one sheet is handy. Okay, the sheet is in the chat.
The sheet is in there.
Mhm.
Did you say Casey?
It is. Our buddy. Probably not.
And don't forget to take pictures, you guys. And try to write your site name on the pictures, okay?
Yeah. Now on this is my scrap paper. There's so much of it in my closet. But Johnson and Johnson. We're starting that now, so it's like we're squaring. I've only gotten up to like
You're doing the conjugates.
yeah. So first, there's two. There's the square, what's there, and then we're also going to do the norm.
Square or the norm?
Like
10 plus 6.
three, almost 2 different answers.
10 plus 6
You're
I.
doing this, and then you're doing 2 plus 5.
Minus.
Oh, that was.
This, but
And we're
then
getting 2.
this one's negative
That's
1.
I just noticed something, but we'll choose.
Right.
Well, from our answers that we're seeing as our constants.
Because if you minus a negative, it's a plus.
Yes, good. Yes, that is right.
We're all our answers. That's what we're noticing so far. Just check this one because that's one I've never really used before, but that
Oh, no.
one's too, isn't it? Actually, yeah, that's all we've done so far. Yeah. I hope we can at least we can at least log into.
Yeah, locker.
I'm not gonna now be the first one to use it. I wouldn't be the first. It's
You
not.
should be. Just hide the computer if you don't do it.
Well, I don't think you need a computer for these ones. Like apparently you can just log right in on them. Yeah. That'll help my computer because I couldn't even get on the network today. Everyone's emailed me back when I emailed them, like, I kind of need this. It's important.
Is it just 3 groups today? 2 groups today?
So for the norm of 3 plus I, did you get 10?
Yes.
Yeah.
You go.
3 plus I?
I square -1.
10 plus 6I or just 10?
This
Nope,
is the
I
one.
see what I did.
Yeah,
Wait.
Yeah,
but I,
sorry, 5,
yeah, I times -I
Mhm.
is 1.
is +1.
Yeah.
Sorry, I didn't realize which part we were talking about. My bad. Are still doing it, huh? I'm on 7 plus 4i.
So should I do one of the others, since you guys have already done those?
If you want to do 8 plus 3i, sure. Let's see what we.
Why does it work that way?
It's like a weird triple. I've never heard that one. But
Which one?
Area, look at number 1.
yeah, it's for the 7 plus 4i. We have 33 plus 56i as the squaring it. So we got 65 for the norm. And 30, 56, 65 is a Pythagorean triple.
Look at your
It's
coefficient.
11, 12, 13. One. The base triple, it's 11, 12, 13.
Oh yeah, times 3.
Right?
Yeah. Is that one?
12. No, because 12
No,
times 3 is
11,
36.
no. I think that is a base one. There's no common,
That's good.
not a common factor.
Mhm.
Stick on that one.
That we use.
Mm.
So for that, then I go 50, 48, 58, 72.
Squared.
I got 8 plus 6I.
My math. Ignore me. I think it's 54. I said 6 squared is 3 squared is 6. What is
I had a kid today say 1 squared was 2 in my honors class.
I'm sorry.
I was like, whoever said that, multiply it, I want you to square it. Because we were doing, we were getting sine and cosine of all the special angles.
Yeah.
And they didn't remember the 45, 45, 90 trick. So I was
Is
like,
it relaxing you guys or is it boring you guys?
That's what I got for all my problems. Yeah.
We were starting to define
-9.
critical thinking and problem solving.
Nice sandwich. It's not 10.
And 64 plus 9, 73. And then this should be a trick. 48, 55.
And 73.
I should have gotten the other graph. And then I got this for the bottom one. I got 2 of them. I got 241 as my norm.
I haven't tried the last one yet.
I'm just going to double check it because I don't know that triple off the top of my head. Yeah.
Are you still
Did I
sick?
do it wrong?
Yeah. I'm sorry.
Oh no.
Oh, Jen's
Oh.
one looks nice. didn't even see it.
Yeah,
It's like.
it's hidden. Don't take a picture of mine yet. I might have messed up.
Okay.
Oh, because this is 120 high. That's fine. Now let me see if this works. 120 squared. Hello, how are you?
So. Yes.
Okay, it does. 209 plus 120 high for the last one.
For the
Sorry.
last one?
Yeah.
I'm good.
Yeah, my camera. 209 plus 120 high. And the norm is 241.
Like,
So,
I don't know. Did you see like in,
now.
So.
Janelle didn't work for this one.
yeah, there's something.
You guys want to put
Look at the
can you guys hear? If you make a little table of your z,
Oh, you mean like on the left?
z squared, and your norm. Do you guys want to do that on the 3, 4, and 5 spreadsheet?
I'll do it.
So like, we'll just put this, like, we'll make a spread, we'll put a column of that.
Yeah. Exactly. Do you guys want to do that too, Ton? Did you hear that? Or you could put it on your whiteboard and take a picture or something.
Okay, let's do that.
But it would be good to have one to work with.
Yeah, so you can do it.
Yeah. Let me upload your picture first.
Is that what they want?
Please.
Yeah, we do. Thank you, Jen.
Can't type.
Did it wrong. I did it wrong, so you did.
And then that cell, for some reason, is super big. Let me just move everything up.
I know it's not that easy to work with the spreadsheet, but it will be really nice to have that for future. And actually, because you guys had kind of cleaned up your sum of squares table, so a lot of people have been using that. So thank you.
So also they use the square norm. Yeah, okay. 3 plus
Oh, I wanted to figure this out.
And then we have
Look at your coefficients.
8 plus 6.
Yeah.
And the norm was 10.
5
The norm term,
plus 12 I.
and then look at your square.
I think I found something.
15 beta.
Okay. I'll say it again.
8 plus 3i.
How many more?
3. Actually, just 2. Just this one. 8 plus 3i.
Oh, yeah, I did.
The
32 and 50.
The square is 48i plus 55. And then the norm is 73.
You're right, 55 plus.
Sure. 55 plus 48i. And then the norm is 73.
209 plus 120.
And then 15 plus 4i.
It's 241.
The first one is 209 plus 120i.
Okay, yeah, we
209 plus 120i.
can change your word.
And then the norm is 241.
And that's
I
for some reason.
think I spelled it wrong. It's just autocorrect.
Autocorrect.
Figured out the formula.
What do you mean formula?
Like it's
Oh
like whether we're doing tricks. Like it was all day today. Couldn't say it.
What do you mean?
A and B are the
Oh, yeah.
coefficients.
Okay. What else do you notice?
That's what I noticed.
So go ahead and find Pythagorean triple. Well, should we move on here?
I mean the first one, right? 3, 4,
We're just using that.
5.
Well, I was just wondering if, like, there's a whole of the what if we created our.
Okay, do you guys have them all? Chicago, do you guys have them all?
Mm-hmm.
Nantucket, do you?
We do, yes.
Is
All
there
right.
something? Is there something?
So did you guys see anything interesting in the opener that you want to share with each other?
And you get,
Mm.
and when you do like here, you have a squared plus b
Wait,
squared.
wait, Ariel, hold on. Do you want to share it with everybody, including Nantucket? Will
I
you?
don't know if
share it?
I fully know I'm sharing that.
That's okay. That's great, actually. Wait, Donna, I can't hear her at all.
There, because I
Is
muted
that
it.
better?
Yeah, now I can hear
Okay. If you use A and B as the coefficients, so whenever you have A plus B times I times A minus B times I, so when you're finding the norm of the number, the answer is always going to be A squared plus B squared. So the first coefficient squared plus the second coefficient squared. So that means that if you have, if you find the norm of a number, if you take the two coefficients, use it as A and B, those can be two sides of a Pythagoras triangle. And then the C could be the hypotenuse.
Okay.
So the norm would be the hypotenuse.
The norm would be the square of the hypotenuse.
Yes, the square of the hypotenuse. Yes, sorry.
And
And then I
Nantucket.
realized, oh, sorry.
Sorry, Ariel, go ahead. Keep going. Yeah, keep going.
Oh, and then I realized for when you have, if you're still using A and B as the coefficients, you have A plus B times I, and you want to square it. Your answer is going to be A squared minus B squared, in parentheses, plus 2A plus B.
Mm-hmm.
I think she was trying to like just do it like algebraically.
Yeah.
And then
Oh, I see.
these are
Yeah.
things that she
It's just
Did you guys see Nantucket? Did you? Oh, are you still thinking about that?
Oh, yeah, what she said earlier about the coefficient and the norm is like, looks, the whole set is like a triangle triplet.
Pythagorean triple.
Yeah.
Okay, so hold on. Wait, Chicago, listen to Nantucket for a second because I think this is useful. Can you say that again, Yuyan?
Yes, we agree with what you said, that those coefficient and the norm together makes the Pythagorean triple.
Okay, so I think you're saying something a little bit more than what Ariel was saying because you're saying you see the whole Pythagorean triple here somewhere. Yeah. Is that what you were saying, Ariel, or not? You were saying
yes, I'm saying that when you square it, you get the two legs. That's what she said. The coefficient is the two legs. And then the norm is the hypotenuse.
Okay. So let's do number one of the important stuff together. Describe a way to find Pythagorean triples.
Like say we did 4 plus 6i.
What do you think?
Okay, say that super loud. What you're saying, Darren, what you're saying, say really loudly.
Say like maybe just pick two random numbers. We'll just, for example, we wrote 4 plus 6i, and then we can square that to see what we would get when we square it, and also get the norm, and we can kind of check to see if that actually holds true as a Pythagorean triple.
All right, why don't you check that one? What did you say? What was your pick? 4.
I just picked 4 plus 6i.
Okay,
Just-
try that one and see if you get a Pythagorean triple.
No, that's not gonna work. Because then we get a negative.
But what about
We'll
the
see.
coefficient?
Yeah, we'll see.
Maybe it's coefficient.
What if we still square that though?
Is my answer for 3 plus I incorrect?
No, because you do get a negative. It works if you take the absolute value of the first of the constant. Like if you took the absolute value of 20 and that was one side of your triangle and 48 is the other leg, 52 is the hypotenuse.
Mm-hmm.
Just how
Yeah.
Right?
it's
Is a negative.
I didn't do the whole thing.
Oh, it worked.
The absolute
I think it still works.
value will be okay. No, sorry. Yeah. I need to change that. I know it's a super easy fix, but so we say 5. Complex. Let me see if I can read this correctly. We have how it says that if you pick any complex number, square it.
Why does it work? It's crazy.
Should we write it through? Don't know. I keep staring at it. I found it, but I don't know exactly why.
Yeah.
I know.
What is difference of, I mean, it is in all of them, right?
The norm is the difference of squares. Like the norm calculation is the difference of squares. That's why you can just multiply.
If one of the complex number
It's one.
value
Where
squared
Understand what?
is negative.
What
I
Nantucket
just
was,
got lost.
what Nantucket was saying about the Pythagorean triplets.
So they were saying, they said something about plugging in like a random number, right?
Yeah, so you can pick,
Uh,
they just pick any integer for
Yeah.
this and this, and then they squared it, right? And you'll, whatever you do,
So do we? Oh, what?
this number by itself and the I coefficient will be the two
Check that out.
legs
Set for
of the triangle, the red triangle.
And that'll
And then
be
the
the
norm will be that number.
this.
What's that?
Yeah, because you would take an even number, maybe one equal one odd.
One even one odd.
I mean, I tried it with like, I tried it with, I tried it with 10 plus 2. I tried it with 13 plus 15.
I think I'll still do it. We'll still get a negative because we have minus 144.
Did you try it with 1 minus I?
Oh, we didn't do 1 minus I.
No,
Just
I didn't
try.
do it.
So, well, but Karen, you mentioned something about the absolute value, right? So,
Like for 4 plus 6i, when we went through that and we squared it, we
uh-huh.
got negative 20 plus 48i.
Oh, I see what you're saying.
But
Yes.
then if you take the absolute value of negative 20 and make 20 your length and 48 your other leg's length, the norm 52 ends up being your hypotenuse.
Okay. So
we have to
pause
make negative.
for a second. Just wait for a second. Do you want to say that more slowly?
Sure. Yeah. So when we just randomly picked 4 plus 6i and we squared that, we ended up
What
getting
did you get?
negative 20 plus 48i. So what we ended up doing was we found the norm and got the norm was 52. But to kind of show the Pythagorean triple, we need positive numbers. So we ended up taking the absolute value of negative 20 to get positive 20. And 20 squared plus 48 squared does equal 52 squared. So that would be our triple.
Okay, so that worked with your 2 plus I. With 4 plus 6i. Do you want to try 1 minus I?
Yeah.
Anything else you have to do?
oh yeah. So you don't even know.
So we haven't tried it.
It's just a
That's kind of what he's talking about. So it's like these coefficients are kind of plus or minus. If we're
Yeah.
talking about
Minus 2i.
Well,
And then we have plus I squared.
like I think he's talking about like when I did it like for this one, when my number by itself was smaller than the I coefficient, you're going to get a negative number.
Yeah,
So he's just saying
Negative.
so 56,
Yeah.
90, and that's
It's not the real scale. What about the and the norm is
these numbers.
1
oh, well, it's
plus 1.
Like a triangle.
makes sense. It's like those straight lines, like those triangles that are flat.
If it's negative 56,
No height. There's
we're using positive 56.
or the vice versa, or the
Yeah.
there's height and there's no width.
yeah. So he's just I think he's just saying
That's what that. So this would be if we were to plot it,
like
because I think it talks about plotting later.
like
Is it the length of the
Negative 2i is
how we drew those triangles. This I'm just doing that.
It's the
It might be like
vertical.
right. So it's just the vertical line.
like coordinate plane. That one question from yesterday.
Does that
The distance is still.
Yeah,
is still 2?
It's still a near triangle.
right? But it doesn't matter.
That would it's still actual distance.
Yes, it's actually just so it's just
But
distance.
it's still like
It might be. I don't know.
It's still like a weird triangle.
I got it. I got negative 2i and 2. So
You wouldn't. Well, we couldn't really plot the norm on this because the norm's not unless you're saying
I don't
it's
think
2 plus
it's
0i.
Like 2 plus 2i.
It's 2i.
So we have a nice oscillates, right? So we wouldn't have a triple, but this would end up being 2 root 2. If that's like we can't really plot the norm as a 5, but if you can.
You do that.
We're gonna fix one matched.
Yeah.
What if we tried, like we did 4 plus 6i? What if we did 4 minus 6i?
Let's try 4 minus 6.
16. That's 48.
Ton,
Yes.
you asked, why does it work, right?
I don't think it works for this either.
Plus 36i squared, which is right. So you still get negative
two terms, right?
You still get negative 20 minus 48 so you still absolute value works, but this one,
Oh, but you have two negative.
there are two negatives that but
What did you get?
Oh, I'm doing four. I'm sorry. I'm doing four.
that can work when your coefficients are the same.
So, I mean,
Okay, this one's two, that's too bad.
Yeah. Oh, you're
So that's it, right?
I think.
I don't know why it works.
Wait. Okay, Ton, hold on. Stop. Pause for a second. Ton is saying, I don't know why it works. But,
Sure it does.
does somebody want to talk about why it works? Why it has to work?
No, not really.
Well,
No.
that's-
I did it like algebraically. I can send the picture, but I don't think there's an explanation.
Here, you can look at plus yeah, plus 36, right?
Why are you working on graph paper?
Because this is -1.
Yeah, because then you get plus 36.
Yeah.
I didn't know if there was something in there at the beginning.
Triple would be 20, 30 for 48, so.
Yeah, it's 20 plus 48.
Oh, I didn't.
32, 12, and 32.
Why did you do that?
So, what you got, I got the same.
Like, what was the purpose of this?
Okay,
What were you finding?
Right.
It's like, wouldn't make sense to do, because I know that, like, the other proof is a lot easier.
Like polar coordinates, right?
Not for anything that I.
Because do you have, oh, Jeff doesn't have one. It's like a polar coordinate.
At least not
I have to use the paper on the wall.
Because we have like, in our rooms, we have a section of the
That
whiteboard
whiteboard. Oh, yeah,
is
I've seen
a
it,
polar
yeah.
coordinate grid.
It's
Neither of
It's
us,
wicked
neither of
cool,
us
but-
teach classes.
Yeah.
So
This would end
I
up,
didn't do polar coordinates this year, actually.
where do you do algebra 2 or pre-calc?
It's in pre-calc in the master.
Wait, okay, Yuyan, do you want to share this? Do you want to talk through your algebra here?
Sure.
Because I think it's very similar to Ariel's.
Okay. What I did is just like instead of having a number, I just pick a and b to be my coefficient of the imaginary number, and I square it. So I do the algebra, and things cancel out, and then the left side, after you cancel everything out, and you factor it again, it looks like the right side, which is the hypotenuse of the triangle triple.
No one on this one.
So yeah.
what I got too.
So I mean, I just
If
just
they're-
algebraically makes sense, but I don't
You
know
lose your real
like,
number.
why. It's like it should come to me, but I just like still don't believe my algebra. I mean, it is, but I just don't see I like a deeper understanding of.
Okay, so let's go for a little bit deeper understanding by moving through some more important stuff. Why don't we take the next little while? I don't know. We may stop, but let's say the next half hour for now, just to keep working through important stuff. And you may see some other connections that feel more satisfying. I find this explanation really great and like, oh yeah, but there may be others that appeal more to you guys along in this important stuff.
I don't understand.
What, Jeff?
I don't understand her work. I can't see it long enough to figure it out.
I think this, let me finish it up.
It's on Flickr. It's on, so if you guys go to the Flickr site, you can see the photograph there.
It's not on Scratch or Slack.
Oh, Slack. Has anybody posted anything else?
I'm just trying to do it.
We are the slackers, you guys. Everybody is the slack. But
But then I think it's this.
yeah, if you get Flickr, you'll see it.
All right. So just square it. If you square it, you're going to get an A
Why am I
squared.
squaring it?
Because that's what we've been doing here.
So A and B is your two coefficients.
Mm-hmm.
Okay, not the two, like, not these ones.
Yeah.
Worse.
So
But
it's like 2 and 1 and 2
so A
2
is
plus
A
I.
is 2 and
one
B is 1.
Oh, I see what happens. Sorry, Darren. Just
No, you're good.
So you square
And then
it, you're
yes,
gonna
and
get,
this is what Ariel did, right?
So there's
and then I simplified. I got rid of this I squared. We
I
know
did
that that's
too.
-1.
Right.
So then you
I
get
did the same thing.
A
That's
squared
exactly what I
plus
got. Yeah.
B squared equals that.
Yes.
And then you do the norm.
Yeah.
And you get A squared plus B squared.
Your X
Yes,
and Y
that is
are
where I'm at also.
triangle, C is the hypotenuse.
So
How are we getting our coefficients here when they're squared?
It would have to be a Pythagorean.
the coefficients will be so
This
somehow.
is what I'm trying to figure out. What is,
Like the connection.
well, how can we, so this is
Yeah.
is B squared. Right?
Yeah, I don't know.
So should
like,
these
how does
coefficients be like
this-
C and B?
But
Yeah.
didn't help in this part.
C and B?
Still trying to figure out what I
No,
squared.
the C squared plus D squared.
Because you know what that is.
I grew up
Well,
Because
there's
this,
no, there's
so
no
what I'm
need-
saying though is if
Three
it's 3
squared.
squared plus 4 squared equals 5 squared,
Get that weird kind of
Right.
personal triangle.
but these, that's not the
How
same as
does
2
this
squared plus
produce,
1
how does
squared.
that produce that?
Right.
That's what I'm,
Yeah, I
When
don't know.
head on it, look.
because if this
Like
is
I'm
A
trying to
squared plus
figure
B
that out.
squared and this is supposed to be.
It is a triangle.
And how does, how does norming?
In a complex plane.
Because these, yeah, they're not the same.
Oh,
So we should
So this
retitle
A
this
squared
A
plus
squared.
B
But
squared.
literally,
is
not
every
use
time I
it,
need
we
to know
should-
Pythagorean triplet,
Like
I have to
product
Google.
1, 3 plus 2. Like there's tried to plot. Like you.
But do you know what I mean? That's why I'm,
That's A squared and B
this is
squared,
why
and then
I
I should
don't.
rename. You know what? I'll redo it with that. That should be
Yeah, but if
renamed.
you're looking at it.
Oh,
in X, Y,
that's
yeah,
what
it's
I'm
a straight line.
Two and
But
then one should be
the
different.
one that's in the Z,
That should be like.
it has height, it has width, and it
I think
I don't know.
no, I was thinking back.
Oh.
He's B.
I was thinking
I
like,
think those should be.
We're looking
Well-
for Pythagorean theorem.
well, not even going diagonal, just going straight.
Straight up. Okay.
Straight.
Three and a four.
Otherwise,
That's not a triangle, but it's like,
this B squared equals C squared, which is.
but like, if
Okay,
it's
so
a distant formula, but it still works because we have a length 2, but no height of 0.
But isn't that what we're getting excited
Like
about?
square plus 0 square.
we're getting,
Isn't it, doesn't
we're
it
getting
seem
excited
like,
because like this
So you
somehow
it's just not a,
gives us the 2 legs.
but
of the right
it
triangle.
still works X squared.
And
plus
this.
Y squared.
Somehow gives
In
us
this case, the
the
third
hypotenuse of that triangle.
we can turn this on.
Like forget that A squared plus B squared equals C squared.
Well, there's a power button on the right side.
But just like you don't want Wilson to turn yours on, maybe he doesn't want.
I don't know.
No, I can turn that on. No, I'm just saying like, I'll go into my room. Like, are they, like, they're all ready to go.
so,
Because it's 10 after.
So you have those together.
Okay. Number 4, graph. Should we have
Ton.
Yeah.
how are these the same?
that on?
Why do you still have an I squared? Why don't you
So
just
that's a circle.
minus B?
I did.
Exactly 5 minus
And then this is, this you
This
put
is
at the
just-
end.
into the coordinates. Oh, but the equation.
Because that's actually, I think Ed did that with his pre-calc kids earlier this year. They had used Desmos and they made a circle and they had to put.
Ton, do you want to take a picture of that and put it on Flickr, and then I will take a look at it too?
We do that.
What is the?
This is the same
Could you
thing.
tell me
But
what the confusion is?
we know that 3 and 4,
I'm sorry, Sarah, can you say it again?
that kind of thing.
What is the tricky part?
Not
I mean, I'm trying to figure out why
sorry.
figuring out the square term gives us the 2 legs,
You can also say,
because it's a mess of a expression. It's A squared minus B squared plus 2ABI.
Mhm. Mhm. Mhm.
I mean, it's not that messy, but it's just not.
Still not yet, start
How does that turn into the two legs? I'm trying to find my figure app. Where's your figure app?
all the ordered pairs that would work would be like 0, 5, 0, negative 5, 5, 0, negative 5, 0,
Delete it.
3, 4,
Negative 3, 4.
negative 3, 4, negative 3,
Negative
4, 3, negative 4. Then you also end up 4, 3, negative 4, 3, negative 4, negative 3.
But you'll have an overlap.
And
No,
I I guess, you guys, this is what I would recommend. You don't need to know why totally right now. Okay? You just need to, do you believe that it does?
What it does? Yes.
So you believe that it does. Okay, keep going.
Yeah.
Keep going through the important stuff.
Okay.
Don't worry about that algebraic proof for the moment.
Because all the lists. Yeah. I guess it's saying Pythagorean probabilities would end up making points for a circle of radius. 2, right? At that point? Like points that are up. So if we're doing 4, for example, we're making terrible at making freehanding a graph. But do they do locus in algebra 2 here?
No, it is in the Engage, but
Because we did it in New York.
It's too much.
And we would combine, like, for our locus, we would combine circles with lines, circles with sine graphs, like parabola, for example. Like, because technically, here's your, and then 4, 2, like we're, okay, and then 2.
I need to remove my break. Can't keep my eyes open, I'm sorry.
Should come back to
No, I won't. You know I won't do that.
and because I know my circles are more like ellipse.
And I was supposed to be out tomorrow anyway, so if I called out tomorrow, that would just be cruddy of me.
Oops. Yeah, my badly freehanded circle. And this would be squared plus y squared equals 25.
So that looked like
That's the equation you are searching.
yeah.
I was just about to say that.
It's just my circle was poorly drawn because I didn't space everything out.
Yeah, yes, but I'm trying to talk
So if you're in like a circle, x minus 0.
yes, yeah.
Square plus y.
But I was trying to
Plus, yeah.
What's that?
no, like this looks like the norm.
Y squared, right?
Yeah, this is how we were getting it.
Okay. So maybe that's it. That's
Just
right.
a circle, right?
Like the equation. So the equation of the circle,
Mhm.
and then the norm is the same thing.
How do we find the
The
12?
norm is also the radius squared. No,
Other than
the norm
there's no other.
is your radius squared, right?
Which one? Yeah. this way.
of a circle.
No. Well,
Oh, that makes sense.
So like, if I put
Well, it
that,
would make sense why we got just a straight line.
Now you get a straight line, and then there's a radius.
That would make sense.
I didn't do this very organized.
Yeah.
I'm getting
Trying to.
How do you straight line?
How do you?
add the 4. I get a 3 and negative 4.
I can just use
I didn't organize this at all.
like walking out
2 negative 3, 2 negative 4.
like 2 minutes of not being able
2 4s.
to say for 3.
1, 2, 3, 4, 5, 6, 7, 8. I only have 8.
So they actually do it? Do one of these? Did we already do one of these?
Yeah, I mean,
3, 4,
we
and
did x squared plus y squared
Yeah.
equals 25.
Bring back my 9 ranges radians.
We did?
Yeah, like problem set 2 or something, didn't we? Isn't that what we did?
I don't know. I can't remember.
I just,
Also, I couldn't do a little thing that we were in judge's room. It was so faint.
Oh, I'm sorry. All your markers running.
No,
Yeah,
those,
well,
those
I
are the ones I
purposely-
let Watts
Those are the
use.
ones I let Watts use. we're both in that same boat. Because one day when I went in his room, like I pushed his cart back in his room, and on his cart he had like all of my stuff. He had my thing of rulers. He had all of my markers.
Sorry, I'm doing my,
Those are-
I'm doing like.
what do you guys have?
I was
I've taken a bit of Janelle's book.
not
Slowly
I was
back
trying to prove
to in that grade class.
You would think that they probably would get better markers.
I'm on my way there.
What'd you, you're doing 3, right?
I got 8.
I got 8 too. What are the other 4?
Well, do they have to be full numbers?
It says integers.
Class was just
But separately, we were doing each at a time.
Kids were trying dual, like a battle game on their computers while he was teaching in the middle of his,
I'm missing something.
like at the front.
5.
And it's just like, what?
Oh, 0.
Nantucket, will you guys put up a picture?
Using it now.
yeah,
5 and 0, right?
Oh, 5 and 0.
Yeah.
Thank you.
no, I was thinking,
And then 0 and 5.
Mm-hmm. And that's it.
0 and negative 5.
Norm, and then create.
the norm.
You
The
find a
norm.
norm by the equation of a circle.
Okay. Yeah. Once I once I put negative 3 times. No, I didn't.
oh,
I see
I
picture.
think that we got uploaded picture of the number.
Oh, I didn't see that.
Yeah. See,
I already. I just typed the last coordinates. So.
So, yeah, so the norm of the,
We were saying.
but I was looking at the like, how is like these number 8 and 3 kind of like here's 3 and 4 like kind of show up.
Maybe I'm doing it.
3 and 4, 5 and 0, right?
right.
So
'cause
what
that's
would
the-
these-
The triple, so what would be the triple that we used here?
So like here, if
I don't know the picture plan in here.
we use like so 9 and 12 give us 8. Or no, we didn't do it. So like we we're just sign always get 2.
No, but keeper. I can grab some for you.
Combination of the negative of each of your coefficients. But they all end up being coordinates that make us in the end.
Thank you.
You understand, like here, if instead of using 1 minus I, we use negative 1 minus
What if I
I?
use what if I also use negative 1 negative that? Would I still get?
And Ton, can you load a picture? Can you put up a picture too, just so I can see what you guys are working on?
By the graph of anything we're working on?
Yeah, that'll be good. Just write Chicago on it too, please.
Do I?
I'm slightly.
If you get 1 minus.
Because we get 1.
Mhm.
I'm
and
just
we're
like,
left with 5,
no, no,
which
no.
we would
Be
say,
the other side of
and then you take the norm, the
Mhm.
norm's still 2. So like all combinations of positive and negatives would be like 4 points that you could, in theory, make a circle. And the norm is the radius of your circle squared.
So we'll do it. X percent y squared equals 2 squared.
And then with like, so like 1, 1. Wait,
And then you
1, 1.
factor it.
Or is this a square now, though?
Yeah, but it'd be possible, right?
I'm trying. So like 1. What's this? 1. Sorry, I can't even. 1 negative.
I
1.
think you'd say that circle, but you have to figure out what the other part is, because here they have to be 5 away because the triple is 3, 4, 5. Am I interpreting that correctly?
The triple is 3, 4, 5. But
Right.
then you can also, to get 25, you could do 0
I
squared.
just use it as straight edge.
Mhm.
I'm just using it as straight edge.
Okay.
So that one you have a couple of things, like to get 2. You
Good.
can
Like this is a center.
is 1 squared plus 1 squared, or 0 squared plus.
This is a center.
Yeah.
And you put your
Yeah.
pencil there and just swing it around. But
Let's do
That's right,
0
0 squared plus.
I don't even know what dimensions are.
Oh,
Does it fit?
no.
I know it's not exactly. And period. Simple.
I do have a compass. You want a compass?
Circle is
Actually, it would be.
It would be beautiful. It'd be like really pretty.
Yeah. Sure,
Yeah, the
just-
radius of the circle would be square root. In that case.
What color pencils is one?
Because technically this, to go from the origin,
Oh, this is a good one. It doesn't move.
is square root 2, because then we went over 1 up.
Mhm.
Harder equation than I think.
So, so, and just the more that you have that you can get to that norm, the better you can freehand your circle. If that makes sense? Like, because then you have more points that you can put into the circle.
So the less points you have.
The less points you have, like, yeah, it's almost like approximating time, right? You go further. Like,
Yeah.
I don't know. If I'm
No,
to the
how-
best of my ability.
how you're thinking of it, I'm thinking of it like an integral. But also because integrals are on my mind. But like, when you find the area under the curve, like the smaller you make the distance, the more precise
Yes.
your area is. Like when you're
Yeah.
trying to find the area under the curve. So I
Yeah.
feel like the more points you have, the more precise your circle is going to be, because you're plotting more points, it's going to be more accurate. So
There's some way to do, like there's some way. I did something kind of almost similar to this, where we just kept adding more and more points to where you get a circle. It's like it's somehow improving the area of a circle. Like you keep adding more points to a regular shape. All those points will connect to make a circle. So if you start with a square,
Right.
then if you went to a pentagon inscribed, and then you went to like going on, you eventually get to a shape of points.
Right.
That now becomes your circle. So that's kind of as you
It works.
Same. I'm like trying
Actually-
to sift my brain. I'm like,
I did it with my honors kids last year.
Anything that gives us a
It was like a lesson in its own. Like improving the area of a circle.
yeah, I did the same time. I did that in calculus.
It's actually in like it's in the math standards for geometry, proving the area of a circle.
to be having.
Geometry.
It's like the norm is. I think how to say this.
I say just write it how we just said it.
The norm is the same as the formula.
Ooh. That's cool.
Is
Oh, look at that face. Yay. Wait, stop.
formula.
What did you just think was cool?
Oh, that when I plotted all the points that were 5 away, that they were all the points, coordinate points that I found.
Does that make sense?
I thought that was really cool.
Yeah.
It's sorry, it's not that
No.
exciting.
It is. I think it is too. All right, good. Keep going.
I think I shouldn't be right next to the microphone.
No, you should. You should.
There, I think.
Mhm.
And if I need to explain it more.
You guys can probably hear me breathing.
The way I'm thinking is the same thing, because like when you're saying, like when you're describing like the negative, like when you change the coefficients, like you're like cycling back and forth. Like I'm thinking pi.
Mhm.
Like I'm just thinking of
Yeah.
those points, like you're just cycling back and forth.
Yeah,
Like through the
just
quadrant.
with what's positive, what's negative. It's still the
Exactly.
same distance away.
Right.
Just giving a different sign to it. Like hence
Right.
why we only teach 30, 45, 60.
Mhm.
And then they can use that to help get 120.
Exactly.
Get one, but
Flip it around.
I think. I don't know.
That makes sense how you're explaining it, but I'm in the same room. Like, how do we explain it better? It's
Yeah.
just right. That's the way that it is, and we can refine it after.
Okay, so
If we randomly give them like 3, 4, 5, 3, 4, 5, so around. So I'm getting like 3 instances. The radius square, like the x squared plus y squared equals 3.
I don't think we're supposed to stop thinking about this,
How do we find
this form?
and we'll just do integral.
So
Are there
how does
any?
it tie into Pythagorean triple?
Are
That's
there
what we have to
any?
make the connection with.
Yeah.
Well,
Are there any that?
yeah.
Are there any integer coefficients? Yeah, I can get that.
Well, we got like bound to be 1. Like, it's always there to be 1
I mean,
because of
this one.
No, that one
Multiply x squared times x squared.
integer like points.
That gives you x to the
I forget that calls. It's so small that we.
Yeah, like I guess saying we have like
I mean, this
Yes.
works, right?
so would like I don't know 2 plus 4 i.
No,
4
x squared plus
plus
x
3i.
squared would be 2x.
How'd you get that?
You did multiply the yes.
What that, you know? That was-
And you
Did it?
add the you add
5 was the norm. And
I mean, it was,
Squared
since we're using 3 and 4
times y squared, just x squared, y
The
squared.
norm
the norm was 4 plus,
Five.
yeah,
So what's the coordinate pair? Coordinate
4i plus.
so like 2 plus I.
0.
Is that saying that if we went
4, 5, x
No,
times
okay,
y.
because it's going to go up.
up 1, if we go
So is that
no, it's almost square.
is that coordinate?
If we go
In
Yeah, but these coordinates are from here.
maybe like 2 out of
Well, so-
2.
Oh, I don't understand.
Like, why am
Why you don't
I doing that?
What are you doing?
we're kind of in the
So-
continuation.
It would be 2 plus I and 2
So-
minus I would be the,
We're just
So like
trying
2
to
plus I
figure out
plus over 2
we're gonna come up with 1.
and up 1.
I mean, I see how they get the coordinates
But also you
here.
can say it could also be
I don't understand how it's not the same
2 negative
as before.
plus
I
I
don't
should
either.
give us the same norm.
That's what I'm confused about.
What do you mean?
Like,
How is it
when
different?
three
What was
works in-
before?
How
What
is
was
it
life
different than
before?
3 and 4?
What's that?
Mine.
How is it different than 3 and 4?
It would give us the same
Because we
norm.
found out that the
It wants to know so complex numbers has I in it as
what's
imaginary
what's
numbers.
not. Oh, sorry.
Wait, can we come together for a second? Chicago, do you want to ask your question to the whole group?
Sure, we're on number 5,
Mm-hmm.
and we're struggling. I mean, Casey came up.
I didn't come up.
She didn't come up with a coordinate pair, but she came up with 4 plus 3i as something that you could find a norm of to get 25.
Uh-huh.
But we can't even come up with one complex complex coordinate number.
possible,
Oh wait,
as we could have,
yeah.
the coefficients,
So
right?
are they asking for 12 coordinate pairs that fall under that?
They're asking for 12 complex numbers.
So we can also rewrite this.
But a complex number, okay, so hold on a second. One of the things that I thought I heard was how are 3 plus 4i and 4 plus 3i different? Is that right?
I was asking how are numbers 3 and 4 different than number 5 of the problem set?
Oh, how are problems? Yes.
And
Okay.
so that was so then he was explaining the complex number thing to me.
Okay, good.
this.
That's good. So you see how to graph on that complex plane, right?
5 plus. Right.
All right. So what is the confusion? Sorry. I'm glad you're good on the complex numbers, but
Are they asking us for, is number 5 asking for? I don't know what number 5 is asking for. Is it asking for, it's not asking for ordered pairs. It's asking for complex numbers.
it's asking for complex numbers. But if you were going to write
In the same.
ordered pairs, what would they be?
Which you're gonna have. It's gonna be.
One complex number Casey found was 4 plus 3i, correct?
Yes.
Okay. So what would be,
then
what
what
would,
about, do all these same variations work?
We'll try them.
4i?
Yeah. So what would another one be?
And then
3i?
reverse.
And what else?
3 minus 4i? I don't know.
3 minus 4i. Yeah. Try it. Yeah.
We don't even have to write the zeros.
Yeah. -4.
-3?
And
So
you
get
tried,
8.
Casey, you tried 4 plus 3i because the norm was 5, right? In our original list. Like here?
We didn't do it in the original list.
Oh, no, but here.
I'm just thinking of the 3, 4, 5. The norm we got was 5 for that one pair. But I don't think it's a
That's not why I did. I don't know. I just did it because we were doing about
Here you go. I don't.
Does the 5 work?
5 and 0. But that's not.
5i?
plus b equals 13. Maybe this work.
Wait,
13 we did get.
So we're taking our unit points
Uh,
in complex numbers. So
I'm just assuming.
Yeah.
Well, this one.
I'll try 5 and 0.
complex
No.
numbers. For number 5.
Okay. Are you good on number 5?
I think so.
Okay.
But how many did you get?
So,
According to using
Yeah.
so
The coordinates.
those numbers are all
-5i?
Yes.
Other coordinates. Does that make sense? I can't think how to type.
No.
Contact number for number 5. Oh, I was thinking of the like the number in 4. The coordinates in number 5.
I was like, what's going on? Oh, that's right, because you have the AP thing. Yeah.
Just a couple of minutes.
So what are we gonna say? The core.
Number 4, the coefficient of the imaginary number.
The coefficients.
what's 0i?
It's a
Can we
0.
put 0i? Right, but that doesn't count as a complex number, then, right?
Or the complex
Other
numbers.
complex numbers. 5i.
It is.
Or-
5 plus 0i is still a complex number. Yeah.
Yeah. Yes.
I plus 0i?
5 plus 0i.
5 plus 0i is
So that we
not
can
that.
do.
5 plus 0i is a complex number. Yes.
Really?
Yes. It is absolutely.
0 times I.
What?
What's 0 times I?
0.
But it's still complex because it's really complex. Association.
This is 5.
So a complex number is any number, right, that can be written with real coefficients. It's not, they don't have to be non-zero.
Like first.
But if you work it out, 0i is just 0.
X, we can say that a
So a real number is a complex number.
13.
A real number is a complex number?
Yeah, so a could be.
Well, I
I can tell you that some people don't seem complex, but they really are. You know what I mean?
But then A could also be -5. 12.
Like,
12.
you seem like you got everything together. You dig a little deeper and you're like, no, none of us.
You just find one.
Yeah.
You have the list all.
Yeah, that's
Wait,
12.
I still only have
5 plus 0i, 5 minus 0i, 0 plus 5i.
It would be 12.
I don't know. That's kind of a trick question.
No, I think that's a good question because it does surface that issue, right, Ton? Like, I almost stopped you guys earlier when you were saying it has to have an I. Because
All of these
the
combinations.
coefficient of I could be 0.
12,
Yeah.
Not -12, -5.
Yes.
It's true.
Yes. Got it.
12, 5, and so on.
Thank you, Sarah.
But then you can also do this one. So you can do it on 13.
Can I borrow your brain for a second?
Yes.
Okay.
Let me do this.
You and your different numbers.
Yes. So you're going to add these. And then x,
Oh, wait.
x squared,
Yeah.
y squared,
Oh, God.
Y squared,
minus x squared, y squared again,
Technically.
Y squared.
plus y to the fourth,
Right?
minus 2x
Like,
squared.
this is something you could potentially pick.
Okay.
But if you pick
Yeah,
0
no, we're talking
here,
about
then you have
you
to
don't
pick
need that.
13 or -13.
No.
I wonder if no matter what you pick, and then we already listed all the possible here.
Really
Oh,
add something.
Sorry, I'm not. And
no, norm's 20.
Do it.
No.
Yeah, the norm is 5, 2 plus I squared.
Yeah, so what we did know the norm was
I
20.
can't get it by the end of the
No, it's almost over.
No, this
You need power to do it,
for
right?
5. The norm is 20.
Okay, in 2 minutes, let's take a break. So wrap up what you're doing. In 2 minutes, we'll take a break and we'll come back together and talk.
So this one for
2 minutes, okay?
For C and D, it has to be 2.
Oh, yeah, I forgot about that thing.
Instead of x and y, it's a
No.
And if it's 1, 2, D would have to be one of the ones. And D would have to be one of the 2.
So are we saying that R squared is equal to the norm? That's what we're saying. Given the equation of circle, x squared plus y squared equals R squared.
D. And D. Oh, I didn't need that.
Right?
So the norm.
Can you say it one more time?
Squared.
I was only doing a.
So maybe this one,
The norm of a plus bi equals to
the norm 13 of 160.
It's different variables, right? So
So it has to be
Y squared.
The norm's gonna be 13.
3 and 2. Oh, so
We can
Yeah.
fix this. Because the norm is 5 and 13, right?
I already.
4 and 1 works? 4 and 1 works.
Sorry, my OCD.
Oh, no, because this is,
Oh,
that should be
C and
25.
D, yeah.
Erase well.
Yeah, I'm sorry.
That's fine.
I
Not
like
true.
I think it'd be really good.
That is true.
Okay, you guys, let's take 15 minutes, okay?
Yeah. Yeah, I will see you.
So 5:35, 6:35.
All right. I go try to turn the board on.
Yeah, let's go explore.
Yeah. Curious.
I just feel like it's so shiny. Fun.
Hi, Jen. Okay, is everybody ready to come back? Almost close. One more minute, maybe. It looks like Nantucket's not quite back yet, so. Ton, do you guys want to unmute? Thanks.
Yeah, we're up. We're back.
Jen, so would this be the same as 4
X squared, Y squared.
x, y squared or no?
So
What is
Because the 2 goes to everything inside the parentheses, right? So if I pulled the 4 out, then the 2 would still go to everything in the parentheses. So that
did you
would be
calculate
the
it just
same
this, or
thing.
did you calculate it with
I think
numbers?
that would work. So what helps me a lot
I don't
is
know
when
what for that.
I don't know.
I mean, what used to help me when I did this was I used to plug in other numbers.
I mean, it's 2 and 3
So
and 1
2,
and 2, right?
times 3 times
And
5
I guess.
squared, right? Was the
Yeah.
same as 2 times
Yes.
3 times 5, or sorry, 4 times 3 times 5 squared.
1, 2, 3. 1, 2,
Does that make
2,
sense?
3.
Yeah, so 2 times 3 is 6 times 5 is 30.
3 times 5 is 15. Right?
30
So
times
15 is
30.
squared.
And 900.
So
That
just
would be the
ignore
same
just
as-
ignore the negative ones right now, right?
That always helped me with my head too.
Yeah, 15.
Then you calculate it with 2 and 3. Is that what you're doing?
Mhm.
So 1, 2, 2, 3.
You get 900.
For the first
I did
Yeah.
2 plus
And
3i
15 times
times
15 times 4.
1 plus 2i.
15.
You do it the other way.
125.
That's
You
what
do
I'm,
it that way.
that's what I'm doing.
No, you did
Then yes.
2 plus. Oh, yeah, you did.
Okay, that's good. Good news. Thank you. This is great news. Yes. Oh, thank God. I was praying because I was like, if that didn't work out, this entire thing, I would just stare at it blankly.
Yeah.
Because with B, this is going to end up. Is it going to have to end up with a norm being square root of 25? Or sorry, square root of 5?
Yeah. I feel like I'm too much over sets. It's like one example.
So we
Well,
For
this works out.
yeah, we got 5 of those down.
and then we were just talking about the fact that 13 is the norm because in the previous one.
Right.
Square root
And
is
so
5.
5 would be
Yeah.
C
So which
squared.
one will we get? 13 as a norm and
It would have to be
Uh,
2.
13 as the norm. We had 3 plus
I would just do the norm first.
Then
Ignore
you can
that.
always you
Ignore
can
the equals 5.
where the 3 go. What's
So that's
positive?
what
What's
you were writing
negative?
out. You were fixing
Starting
those.
to yeah.
That's where we left off.
And that's going to equal.
We're saying if we said so if we just took what we used
So-
from
Yeah,
there.
like, are you
I'm just trying to figure it out.
Yeah.
are you trying to connect this with the? I wouldn't do that. I wouldn't.
And
I
then you
wouldn't-
also have every single
That's right.
I wouldn't say that A and B are legs and C is the hypotenuse,
A could be
Negative
negative 3, B could be 2.
right?
A could be negative 3, and C could be negative 2.
And then put it up.
A could be, I'm just going quadrant. Like, that's quadrant 1, quadrant 2, quadrant 3. A is 3, B is
So if you look at 3,
you can also
3,
flip it.
4, and 5.
Yep. And A is 2.
What we did, that 25 would have been the C squared, right? Because we were looking at 5. The distance of 5
The
away.
squared stuff is
Yeah, right.
right after you
That's
square.
why I'm not bringing it right now.
But if you look at it,
It's
was
quarterly.
My kids are actually getting better this year than my
the
classes.
norm of x plus y
It's just a
I
lot of explaining.
equals 25. That's what it says on the
Or
five.
maybe just
Mhm.
And all of our lengths were 5.
matrices and some kids are like, what? Like even
The actual
after
length
it's
was
not
5.
argued.
That's what we thought.
Nope.
Would be negative 3. Yeah, so, and then we were talking about multiplying today, and I was doing straight out multiplying.
Radius is 5.
Let
The
me
radius was 5.
problem where,
The radius of these would be
and I think that's all I can get.
square root.
But if we said, say we just choose that, so we have,
Yeah, that works.
I'm just
yeah, maybe, let's just say 3 plus 2i.
2i.
And we're gonna take that and we're gonna say,
All right. Why are you doing that?
I don't know.
I got
no,
the same
for
thing.
c plus di, that's 5. So that's gonna put this to 1. So we can say,
I got this.
If you ever have
Same
a
as
break
you.
ton, I proved it for you. One
And
in a lot of
Is that
ways.
negative 60?
the norm if we multiply
We
these
multiply
together.
those two by
That's
each
why I
other.
was doing it.
You read number 7?
3 plus 2i times 2 plus I. We get 6.
So now we should be able to.
49, 16, and 65.
How did you get that?
That's
Because
4
I did the work.
plus 2i squared. 6 plus 7i minus 2.
Is that right? No.
Plus,
We got it. We got that one.
4 plus 7. So, and then the norm for that.
That doesn't even make a triangle.
No.
Are you on the first one? So for 13, I was looking at these. What it has to do with 5 and 12.
But I'm gonna try it.
Yeah, you got something. It's right there.
Oh,
And we know it's 33, 33 and 58 odd.
We put it in 1.
so I'm sure if we took any of these,
Hang
we
on.
would get that.
Oh, let's try.
Times this gives you this.
That could be.
I wonder if you do this times this, if you get this.
And you get that one, just from the way they have it set up.
I wonder.
Uh,
The
I
next
like
one,
patterns, I like puzzles.
problem 6.
this is problem 6. And then type it
Because
in.
it's 33, 56.
Which we already
16,
did.
49, 65.
Right, and that was this
Yeah. That's kind of what we have here.
16.
We do actually. Because we have 7 I plus.
With here, with X, Y on there with.
We have -4.
No, we didn't square that. And we squared this.
Of 17, but you could get anyone.
Yeah, the norm 17 was the 4 plus
We
5.
get 33 and 60.
I'm gonna square it.
656.
The norm is
If
13,
you're like, if it weren't for the last one.
5 and
It's
12.
8. How many ordered?
How do we get 5? We 3.
I'm just gonna
No,
type
you're
in the stuff that's right for
Yes. If you did 2i plus
Sorry, 3 plus 2i.
3 or 3i plus 2, and square that.
Plus 2.
Or last time it was, we used 3 and 4, and you got 5. Right?
What's the 3 plus 2?
Well,
Yeah,
we got 3 and
1
4.
more. So
We
2.
got 3 and 4 by doing 2 plus I squared,
Did you do it?
right? Yeah. Right? 40. Yeah, 49.
Okay, so can we do this then with another number? So if you have like a triple with a hypotenuse of number blank, can you go backwards and figure it out?
1 plus I is 0, right?
1 plus I? It's just 1 plus I.
If I were to change I to, it wouldn't change because I, well, I is the square root of -1. Never
Yeah.
mind.
You know what I mean? If somebody gives you a hypotenuse.
Let me write this down, just so that.
The equation we wrote for 4 was x squared plus y squared equals
For which one?
Square.
For 4.
4b.
4b, for plus y squared is 25, or x squared.
It's 7 minus 4. It's right.
Minus 4.
Right.
Next
Well,
one.
we took a picture.
We took a
for
picture of
four.
it, it's fine.
Oh, say about them, so
That much that little help here, so if we need to.
I think that's what you get when you do the, when you find a norm. Because you end up with x squared plus y squared equals z squared. And then these are, this is everything that came out of 25. So Ton, I understand what my issue was.
What?
It should have been
I like to,
squared.
this is my norm.
It was the opposite problem I was having with 5.
The kids come in like
I was having the opposite issue with 13. I was thinking that 13 was squared when it wasn't squared.
she charged it earlier. We're listing out all the 169s before.
Well,
Is that what ADIS asks us to do?
Another triple.
So like that. I want to upload one. There we go, camera back.
Is there another triple at 65? Isn't there like,
Yes.
it's like 64?
Yep, something 64, 65.
Is it 2?
No, it's not 2. It's bigger than that.
7?
no, I'm just.
Y squared minus 64 squared.
Yeah, I got wood. I'm gonna fix that today.
So they're making
It's not 64, it's 63.
Or it's 65.
Yeah, it's 65 minus 63, square root of 256 is 16.
So 16, 63,
5 plus 1?
64.
That
No.
And then I square
I
it.
can speak today.
Speaking has been,
I'm gonna give them a nice color.
16.
They're gonna want
but is that's not giving us a norm of 64.
I like it.
So that would be 33 and 56. If the hypotenuse is 65.
This one, though, this would give us a norm.
Is 65. Then
It's another triple, like that's 65. No, 65 just happens to be the hypotenuse, but it doesn't give us a norm. I'm like,
I know the measurement, it just still doesn't elaborate.
Well, we
What
need
else
to
I-
figure out what the coefficients are. Plug it in.
So
Will we
7
get a
and
norm
12.
if we use those values?
well, 7 and 4 gave us the 65.
How many?
Norm.
Well, not
That's what gave us.
Yeah.
Can
So we have
65 is 65 also x squared plus y squared for another way? Because that's our whole thing. So like this is now going back to like
Mhm.
however long ago that was.
That's what they mean.
17, for example.
Oh,
The only way we got 17.
Oh, yeah, that's right. So this is.
There's no other two perfect squares. that
No,
give us
that will give us
17.
the time.
So 17.
and then all the points that
All
Yeah,
the
we're this
pairs.
are all.
You're sorry.
So what are we on now? This is
And
eight.
then you just
Yeah,
use
so
that.
am I writing? That was 5 and 6, right?
That was for 5.
Does it equal 25, which is 5 squared, the norm squared?
And then 7. This is just our
Like
eight.
everything that we're doing here is like
7.
exactly the
So,
same.
That's fine.
so that's the 7.
I don't know if it lines it up on purpose or not, but.
You should tell them. Thanks for lining it up.
There would be 16, 49.
It's all math.
That's 5, right?
It's just like everything that we're doing, like I feel like mirrors exactly what I'm doing like that week. You know?
And that's it for
My
17.
kids just
So
started
it-
quadratics today. And it just
Just social
very
media
similar.
accounts.
17 would give us, we could do 4 1.
Social media accounts.
Yeah, Big Brother.
I track you.
Oh. Well, it's convenient. It's okay.
And also get
Is it 8? Did you get 8 or 7? Norm of x minus or x plus 7 y I.
So it's like,
All right. Let's look at your thing. Ariel.
it's like 1 plus
I'll
4i,
look at you.
right?
I put it all in terms of X and Y.
Probably 64% plus.
If you don't understand it,
charge
I can explain it to you.
my laptop's like dying. Okay.
It's yours, sorry.
It was just essentially this.
Just hit Control Z.
Oh, there we go. No, I just wanted to really go. So we'll say, sorry. I keep reading that. 653. Just I don't know. But that might be wrong. Because the norm. Sorry.
Integers per second.
I'm just looking to see what you're.
Oh no, with a hypotenuse. So that would give us the triple.
We just looked at
16
Oh,
squared.
13.
What?
It's at like 9 and 4. So it
Squared.
would give us 13 and those are both squares. So we use 3 and 2
This is
4
4
7.
squared plus 7.
So I messed up.
and 4. And then for this one, it would be 4 and 1.
Right?
So that brings in what you guys did.
It's 4 squared plus 7 squared. That's how we got the 16 and 49 to give us 65.
That's not the triple.
So how you got like 17, 19, 65, 85.
How do you know that that's a
16.
Because that was the
16.
coefficient that's what would be the coefficient.
16, 45, no, 16, 43.
9 gave us the
When
norm.
we did squared, so
Minus
3
Two and
would be
up.
A
the 16.
Okay.
So our triple is
and
16.
4 would be B.
right?
So 3,
But how do you know?
Integers part.
How do you know x squared minus
49 would be
because that's the first number, like when you plug it
I'm
in.
like, my brain is.
So
You're fine.
X here is
Back in and we were out too long and the lights were off. So we come back in and the room's totally dark.
Squared,
Correct.
1 squared.
Sorry,
No, just
I was just gonna say.
is
Wait,
3.
no, hold on. Did I do it wrong? X
It,
squared
it
minus 5
is.
squared.
So,
Now
Wait.
2 squared is 4 minus
7.
1 squared
It's
is 3.
But
That
how
is
did
3.
you? But how did you get that?
Because
Yeah.
whatever,
okay.
like whatever this ends up being, that's what your number is going to be.
My handwriting.
But like, forget the A, it's always going
No,
to
someone took my hand.
be right. Like x squared minus y squared.
No, it's the kids
That's
that didn't
going to end
get
up
that.
being a number.
I saw Douglas using it today and I forgot to
This
tell him.
number
Douglas is awesome. Though.
Let's
I
see the
like this a lot.
2x.
We're on 8.
So like I took
So what we
So
did,
there's 6.
yeah, so what we did with 60, I think we were doing that as we left.
I just said
Like
whatever this
values for A and B possible, and then I didn't want to do it all 15, but so we picked
B
3 plus 2 and 2 plus 5.
Mhm.
We multiplied it together, we got 4 plus 7. So the norm for that was 65.
Okay, so explain this to me. 2x. X is 2. Y is
A
1.
multiple of the triple.
That times that
It's
is
triple though, because it doesn't equal 65 squared though. Like
Oh,
4 squared plus 7
Like,
squared
it's
is
just-
squared.
It's just
X squared minus 1.
triple. Found there was a triple that was 16.
it's how you would solve it anyway. Like x squared.
Because 16 squared and 63 squared equals 65.
Like that's how you would end up with that number. Otherwise, that number is incorrect.
Triple B 4, 7, 13.
X squared.
No, because 4 squared plus 7 squared is not 13 squared.
But
Yeah.
it's not like it always, like that's the rule. If it wasn't like
Because there's
that,
no,
it
like,
wouldn't
65.
work.
You did it for
Yeah.
I think
Does that make sense?
So
my brain is dysfunctional.
Like I just took
we
whatever
were
was that.
working on number 8, like all the ordered pairs that could
And I
give us
called it
17.
Right?
Mhm.
So like all of those first numbers are going to be
This
called
was
A.
17, we were thinking about like
Later on when
be
it's like,
x squared plus y squared. The only thing we could think of was 4 squared plus 1 squared.
mhm.
Because there's no other 2 perfect squares that
Mhm.
add to 17,
Okay.
right?
Yeah.
And then 65, we know 65 is 4 squared and 7 squared.
So
This
just
I feel like that's another way of 65 is also 64 plus 1.
for 1 8.
And
I started it
it could be
when I was determined.
64.
It like it. I felt like it was not super simple, but kind of simple. Just
I don't think,
needed to
I think that's it.
down numbers to feel.
This one was 17.
Yeah.
One thing is like, if
That was
you
actually fun.
multiple,
Pretty much.
like if it's factorable, there's multiples. Or something like that. I don't know.
Based on what we were talking about last week.
Mhm.
It all continues.
Everything is like going on next. So this means we can get everything with 8-1 flip flops, like 8-1, negative 8-1, negative 1. Separating negative.
There's one mistake though.
I don't know what they do.
We also do the same thing with 1s, 1-8.
I mean,
Should
this
just
is
say
why
the easiest way to do all this.
169 would be
Plus 1 is 3.
144 plus 25.
And 0 squared plus 13 squared.
Yeah.
Say that's minus, comma, plus or minus 1. I don't know why I didn't think of this sooner.
I know.
Plus or minus 1, comma, plus or minus 8. There we go.
Yeah, it's like 1 is
I bet you only got 8 for this one.
That's why I use 1
So this one we're gonna get
in this form.
16 altogether because we have plus
Then
4.
you get 2 turns.
No.
No,
In order to get the 17.
no perfect
But
square.
like, no matter what you put in of the 1 and 4, you always get the same thing.
So that's
How
what
does,
that.
how does it help you find different numbers?
That only
Like, I won't just keep finding the same thing.
No. 13.
You know what I mean? Like I did 1 plus 4i, and then I did 4 minus I.
I need to find that the table.
Is that
No matter what.
Good, triplets count.
Mine's wrong.
No.
But this is a different table.
Was not done.
What other?
Not the one. This is
Oh, we did
track.
this.
We haven't.
No, we did this work. It's a different,
Formula.
I can't go up. This was the one where we did minus XY.
Every number is a sum.
You gotta go back.
No.
Session.
Wait, what you're.
No.
C.
Yeah. We didn't go up to 169 though in that chart though. Remember, we only stopped at like 96 or something.
Yeah, but then we added the same numbers.
I don't think we went up to that.
No, we didn't.
But 169 was 0 plus 169. It's also, we got
13.
25.
Have you guys all done 6?
But I think you're right. I switched it. I think I fixed it.
Yes, we have.
What number are you working on?
We're on 8.
You're on 8. Great.
We're working on 8 too.
Okay, that's great. Could we just talk a little bit about 6 and 7?
Sure.
Okay, so who would like to talk?
I can go for number 6. When you're finding the norm of a plus bi to make it 13, I noticed that if you look at the first, the opener, if the norm, when the one that was 13 for the norm was 3 plus 2i, so you could easily just look there and kind of solve that a is 3 and b is 2. And the same thing for c and d. When the norm for the opener, we found that 2 plus i, the very first one, the norm was 5. So you know that c is 2 and d is 1.
Agreed.
And it was
That's exactly what we did.
Great. How about B?
We calculated.
Okay. With B, once we multiplied, we found that we got, again, one of the complex numbers from the opener. We ended up getting 7 plus 4i.
Mm-hmm.
And that gave us the norm of 65.
Mm-hmm. 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 And did anything strike you about that 65?
Remember back, well, the 4 squared plus 7 squared, it could be written as the sum of 2 squared. But, I'm trying to think, I forget what else we did something 65 last time, I feel like.
We did, but also it's 13 plus 5. 13 times 5, right?
13 times 5, yeah.
13 times 5.
yes.
And those were the norms from the, weird, from number 6. Okay.
Yeah, like we had 2 cans.
There are these.
I actually didn't just think that. It's cool.
And we multiplied them.
Mm-hmm.
So does that work? If you're
So
to take
it should hold true.
for other
Yeah.
ones as well.
Because if you multiply a plus b,
Oh, so saying that the norms, if we multiply the norms,
you will get
we'll get the same norm as if we took the 2 complex numbers and multiplied them together.
so a plus bi times c plus di
Is equal to the norm of a plus bi times the norm
any times
of
nb.
c plus di.
Which is like a hard version of the distributive property.
Yeah.
Literally.
Yes.
Yeah.
But it's very nice that it works, right? I mean,
Saves time. Saves time.
how about 7? What did you guys do for 7? Once you had done it, right?
7, 4, 65.
Aren't you glad I made you write that up on the whiteboard?
33.
33, 56, 65. Yes, yes. Sorry, yes. Yeah, that was really helpful to have up there.
It's nice to have it. And now, thanks to Nantucket, we also have it on the spreadsheet. So you guys put it up on your board. They put it on the spreadsheet. So it will be there forever. Okay, how's 8 going?
It's going.
It's coming.
Yeah.
They figure out
See how to find
1765 and
Yeah, for 1765, we have some numbers written. We can upload that. We're trying to figure out if there's more for 169 than what we have.
I'm wondering.
So how did you find them for 17?
For 17, we kind of thought back to the x squared plus y squared chart we did quite a few sessions ago. And we realized the only way we can get 17 with the sum of 2 perfect squares was 16 and 1. So that would mean our coordinates could end up being, or our x and y values would be anything plus or minus 4 and plus or minus 1. And then you can also flip those around to have plus or minus 1, comma, plus or minus 4.
How many did you get? 8?
We had 8 coordinates in the end for that one.
Yes.
How did you guys do it, Chicago?
Similarly.
Writing it up there was made it so much easier, I feel like.
But we didn't do 65. I didn't do 65. Did you do
It's
65?
just gonna be 7 and 4. Plus or minus 7, plus or minus 4.
So again, 8.
For
Just
which
8?
one?
65? Because when the norm is 17, you're using 4 and 1 in your original x and y. That's what he said. Like it was plus or minus 4 and plus or minus 1.
No.
Well, how many, Nantucket, how many did you guys get for 65?
Plus or minus
We got 16. So we had 64 and 1 can give us 65. And 16 and 49 also gives us 65.
Only one I don't know is 169.
Wait, 1 and 8?
So you can do anything with 8, like plus or minus 8, comma, plus or minus 1, and then also flip those to have plus or minus 1, comma, plus or minus 8.
We did. We did the one.
Oh, yeah.
We did the one before.
Why do we care about how many there are?
Well, it's increasing.
It's what?
Not here. And then actually 169, though, it doesn't increase, which
No.
has a few fewer.
So then what's the pattern? Is there even one?
I don't know.
You don't, hey, Ton,
Yep.
you don't have to care how many. You have to care that there are some. For this course, you have to care that there are some. But I think it is interesting to figure out, we're not going to solve this today, but can you find them all, right? Like that's another big question. Okay, you figured out the way to find Pythagorean triples. You figured out the way to find these ordered pairs, these norms, but can you find them all? And how many are there? But you don't have to care about that tonight. But still try 169.
Doesn't work. Minus 4 squared.
I mean, yeah, 144 and 145.
Or minus 5 squared. I think that's all we have. We already have 512, so we're good there. Yep.
13, 144, and 25,
Squared minus 7 squared.
169,
What do you got so far?
8 squared.
13, 12,
9 squared.
5.
Sorry.
169.
We did this work already with this.
I'm trying to find the internet.
Right? No problems there.
Yeah, these are the only ones. So yeah, here's your 8.
How many did you get, Nantucket, for 169?
8, 3, 4.
Just regular sum of 2 squares.
Well, altogether.
12 altogether. Okay, don't give them away.
I won't.
Wow.
Hold off on the picture.
12.
There should be one more.
Ton.
Yeah.
It's going to make you so happy to see the other 4.
Because this one is the only one that can get.
Something else. Yeah, it's a perfect square.
Yeah,
That's-
115 and 0.
So,
Yeah, it's confusing.
yeah. So
What's the other one?
we'll have a norm, have a part of the coordinate as 0 inside of oops. 7.
Don't work too hard at it. What's 169? Like if you just think about it, what makes 169 special?
0.
It's a perfect square.
It's a perfect square of what?
15.
Yep.
Square. Right. That makes sense.
3 and 2.
Part of a coordinate be 0. This norm must be a perfect
Mhm.
square.
Yeah.
Because 13 is a norm. So
Oh,
it's
yeah,
like
yeah,
a norm is another norm. So it's got to have something to do with like 3 and 2 and 5.
We have 5 and 12.
Oh, I do have 12.
5 and 12.
We have 5 and
Yeah, we have 12, right?
Yeah, but can you just take a picture of it and hold
And
on?
these stuff.
You can at least take the picture. Have it like ready to go.
I have them.
This
There's
time.
only 2 that makes 169.
Okay, did you get 12?
Yeah.
All right, so work just for a few minutes, just for a little bit on number 9.
Oh, right.
I was thinking we needed.
Just in case.
20 is a integer.
No, I was thinking we needed 20 pairs.
Oh. We only got 4.
Because we have 8.
Or sorry, 8, yeah.
I tell you, I did.
Oh, actually, wait.
169.
I don't know why. I don't know what's happening in my phone.
So
But
when you end up
number 10
words,
or number 9. You can choose. You don't have to do both. But choose number 9 or number 10. I think Nantucket, I'm not sure, but I think you guys, I don't want to give anything away, but I think you guys should work on 10.
okay, because I think this is kind of what you did.
You then did number 9.
Yeah.
You just used the instead.
But that's not why I think you should work on 10. I think it's because of Janelle. I think from like a couple weeks ago.
Oh, yeah. Because didn't we go back to our chart last time?
Does the squaring method generalize all Pythagorean triple? Like all complex number always.
Because you're M and L.
Wait, that's simple. Is there a triangle triple that we cannot write complex?
That's a complex.
Where are our notes from last week?
Isn't it up
Yeah,
here?
probably in my. Oh, our notes from
No,
last week.
Yeah.
Yeah.
Oh, like
Oh.
handwritten notes or like?
Our handwritten notes are somewhere in my classroom.
Oh, yeah. What about what did it?
You talking about? So we, towards the end here, this one here, looking at the x squared plus y squared minus xy table, Janelle notices that 63, 64, the number 8 are numbers we can get from the x squared plus y squared minus 2xy. It has a real solution for the quadratic.
Number 8 now.
And then we end up writing a formula x plus
Does
y.
it look like the one we have in front of us?
If we were to,
The control plus.
sorry.
Sorry, I'm pulling. Yeah.
Sorry. Just get out of
You ever? You're just, yeah.
They just hate me. But those were-
Or numbers between that.
You guys don't have to prove, if you're working on number 10, you don't have to prove it. But
But does it
Think
generate
about
all triples?
Right.
Like it generates all triples.
So
We said no.
You're doing 9. I'm doing 9.
Oh,
You're doing 10.
Because we tried, and I wish we had our thing, notes. We don't need
The
them.
table.
Yeah, there was some that we couldn't from that method.
I'm playing with that and then you know the answer.
Yeah, which one that we?
wasn't there one with 7?
75.
7, 20, 21. Is that right?
That doesn't ring a bell with me.
5 squared.
No.
Something.
Is it 17? Is it
It was 17. There's 5.
Margins.
5, 7, or 8.
Trying with numbers.
8.
8 something.
Number, what are you doing? 9?
8, 15, 17.
Is Jen coming back?
I don't
That's
think
fine.
so.
8, 15. Is he still on the AP night?
And he could be answering question. I just like.
Maybe this is just an all font. Has a lot of dust on it.
8, 15, 17.
8, 15. Okay.
Yeah.
Okay. And then let's do the norm. Let's do the imaginary number. Is that?
Because we
These are the triples.
I was wondering.
Over and over and over again.
Didn't you have to go through
I
this?
don't understand that identity.
There's a.
Because, like,
Can we pull up the session from when that was? Or was it all in one table?
I don't know.
I have to like.
We did. Look,
I
look what
know.
behind you.
See it.
I just don't understand where identity comes from.
oh, because,
No.
like, because with the whole norm, wait, at least some squares. Because this, I don't think you can,
Identities.
you don't get 5 as a norm.
Not from the triple. Let me see your first sheet from tonight. When we got a norm of 5, we had 2 and 1. Well, 2 and 1.
Maybe area.
So it's 2
Technically,
plus I squared
Don't know.
for the norm of 5.
so like,
Use number 9.
we had 5, we had 5 as
Doesn't
well.
number 9 like look like your proof area?
Yeah.
We had
Uh,
5.
yes, it does. It is my proof.
Colorful
I use next to mine.
Yeah.
Should we send it?
Are we looking at the X squared plus Y squared right now?
Yeah, is that the.
Was that the one you wanted to look at? The X squared
X
plus Y
squared
squared?
No.
Because
But I feel like that's exactly what I did. It's just I use X mine.
X squared plus Y squared minus XY.
That's so funny when you're talking about it. Yeah.
Minus XY was in the other.
It's a
chart.
purple chart.
Yeah, this is, oops. This one is minus XY.
63, what were we talking about? I just remember
I could try this.
all of the triples. Some of them.
I feel like this is kind of what number 9 is.
Which one was it?
Did you have before a kid say hashtag means
Yeah, the same.
Have it.
It would be on this from the last time.
And I was like,
Something.
like I mean I understand why they I understand why you would say that, but I
While other triples do this.
I was like, no, I said number. And I was using it, and a kid was like, "Wait, hashtag."
We were talking about how
Like it was just like
there are
it was mine. And I
I
was
always
just like,
wrty that symbol
from the
when I come up
base.
with problems too. I wonder if they think I'm writing hashtag 3 through 8. It totally could be. I'm trying to be cool.
See what comes up.
But I'm really just telling them like
I'm gonna
numbers.
search.
You have to do like
10 or 9.
but they totally could be thinking
Colleen.
hash makes their homework
I
safe.
was saying like we didn't like we get these triples, but not
I
necessarily.
wonder if they that's a
I was
good
like,
question.
this is
All
that,
triplet
like,
and
We
triple.
necessarily didn't
Yeah,
get
we're
triples
talking
that are
about, so maybe they just
not
think I'm writing like
We-
hashtag 5 through 8.
That's the word.
That's Colleen.
How's it going, you guys?
We just uploaded. Ariel did number 9. That's why she was quiet for a while in the beginning. But she used X and Y instead of M and N.
That's okay. That's
And
great.
we uploaded it on Flickr.
Yeah, that's why I was
so
I was
just like
quiet
if
for a
you're,
little
you're
bit.
trying to see like why this identity works.
But yeah, I did
Yeah.
use
I
X
don't
and
know
Y
either.
instead of
But-
M and N.
But like
Wait, I'm looking for it on Flickr. I don't see it.
You know,
And then diamond norm.
just search 9 because I hashtagged it.
8 plus 15,
Did you write ACK? No, that's Nantucket. Oh,
why would this equal this plus this?
Here it goes.
squared out.
That's cool. That's Ariel.
Square.
But then that's not going to give us
I can rewrite it.
all right, because that'll give us 64.
We need the column.
Okay, are you guys happy with what Ariel did? because Nantucket saw Yuyan do pretty much the same thing. Do you guys feel like, yeah, that makes sense?
Can you guys see it now? On Flickr?
Let me check.
Oh, now maybe 10.
Okay.
Wait, hold on a second. Is there like a lot of cloudy, are there like big bubbles on it? Yes. Okay.
Yeah.
Hold on a sec. Let me share
I
it.
was trying to organize my brain when I was doing that.
Yeah, no, that's great.
Hearts.
It's fine. With like all this algebra in the middle. Hearts all over.
Okay,
That's
so
math in fucking high school.
hold on a second, you guys. Ariel, do you want to talk through this for a minute?
Yeah, so I was quiet because I was doing this for a little bit.
But there's no way.
But I started off with the proof, except instead of M and N, I used X and Y. So I started off by the first like little cloud was I did X plus Y times I squared. So all of it squared. And I solved all the way to the bottom, and then we ended up with X squared minus Y squared plus 2XY times I. If you plug in numbers, X squared minus Y squared, whatever number that ended up being, if you look at the squared column on your table, it was that very first coefficient. So for example, for 2 plus I, you got 3 plus 4I when you squared it. So 3 would be A, and then the 2XY would end up being B. So those are essentially the two numbers or the two legs of the Pythagorean triple. And then I did the norm next. So then I did the norm using X and Y. And then if you solve for the norm, you get X squared plus Y squared. So I just wrote, I pulled out A from the first cloud, the squared cloud, I guess. And X squared minus Y squared equals A. So I kind of wrote that off to the side. And then I got B, which is 2XY. And then I got, when I did the norm, I realized that was going to be C because that you could see that so the norm in that middle cloud to the left, I realized that was going to be C because when you have it on your table, that's what A squared plus B squared is going to equal. So I just kind of went out to prove that. So when I so then I wanted to find out what A squared was in terms of X and Y, so I can kind of align all of it. And then I ended up with X to the fourth minus 2XY squared plus 2Y to the fourth. And then I did the same thing for B squared. So 2XY squared. And I got 4XY squared. And then kind of on the side to the left at the bottom, I did C squared in terms of X and Y. So I took essentially the norm and squared it. And then when I did that in terms of X and Y, I got X to the fourth plus 2XY squared plus 2Y to the fourth. And then you realize that when you add A squared plus B squared at the bottom right-hand corner, in terms of, you replace A squared in terms of X and Y, you replace B squared in terms of X and Y, and then it is the same thing as C squared, if my explanation made any sense.
What do you guys think?
Well, instead of
just explain. Yeah. It's nicely done.
Right.
Yeah, I mean, that's what she did.
Yep.
I mean, Yuyan,
Yeah.
does this feel more satisfying?
Yeah, I think she did it more detailed and like step by step.
Hey, I don't know.
Because I think I left some gaps open, and then she filled in some of these. But I wonder if there's like a picture explanation besides that algebra explanation.
Yeah, right. I mean, I think what I like about what you did, Ariel, is you can really see what the legs are here very clearly, right? And why those are the legs from an algebraic point of view. But I think you, Yen, maybe you're still looking for some intuition.
Yeah.
That's not just, okay, all the algebra lines up beautifully.
Mm-hmm.
So I mean, I think this is, I don't know, Ariel was saying a little while ago that one thing that keeps happening is that she's doing in here what she's doing in class, or there are some mirrors between what she's doing here and what she's teaching. But I think another one is, I think we all really do look for those geometric and algebraic connections, right? And there are a lot of very, very deep algebraic and geometric connections here, and they're going to unfold over the next few weeks. But I hope that is really what you take away eventually after 9 weeks, is this like conviction about the underlying connection, right? That it will be there. It will be there. But this is really nice, Ariel. Okay, just 2 minutes. Nantucket. Can you guys generate all the Pythagorean triples this way?
Janelle said no, but we just can't find an example yet of what.
I don't know if we
no.
can get like, I don't
A
know if we can
multiple?
get 6, 8, 10. Did we get 6? Oh, we did get 6, 8, 10. I lied.
Wait, what?
I'm trying to see which ones we haven't gotten.
How did you get 6, 8, 10 by using Pythagorean triples?
6, 8, 10, I think was one of the, when we did 3 plus I squared in the opener.
Number 8 plus 6 I.
I don't think we got 9, 12, 15 though.
Uh-huh.
And I haven't tried to see if there's numbers to pick to try that, but
All right.
I don't think we saw that one because every
multiple 3, 4, 5. 6, 8, 10 is just a multiple of 3, 4, 5. So you think it would just be like,
Janelle, was it you who said, I just like primitive triples?
Yes.
It was you, right?
Yes.
Okay. Just
some of
checking.
those we were getting.
Mhm.
I think that's what we talked about last time, that we weren't maybe able to get.
There was
But
some
not
balance
skill.
there, but it just starts to like
Skill.
funky. You know, there's a bunch of letters to me. I know I wrote them.
Okay, so just as a spoiler, because we're out of time,
As a norm.
you cannot get 9, 12, 15.
I was gonna say 15, there's no way to get the sum of 2 squares to get 15.
Right.
Right.
So that would be one of those, when we were talking about our columns last time, that 15 would have been in one of those columns we couldn't get. One less than 4.
Yep.
Yeah, okay.
Yeah. You
There we
can't get 15.
We should
There
write
we
that
go.
down.
Before we forget.
Yeah.
So and I'm also going to give you one other spoiler, small. I don't know. It's like an anti-gift maybe, but this does actually generate all the primitive Pythagorean triples.
Primitives, right?
Yeah,
But not.
not necessarily all
Not
factored
all,
ones.
yeah.
Yeah.
But not all of them. But I just,
We were saying like the primitive triples would be possible, but the ones that are not primitives, we're tricky.
the ones that
all right. So I think that's actually a good place to stop, you guys.
Yes.
Unless Chicago, do you have any questions or anything?
Yeah, just to clarify, primitive
15
triples.
Okay, Janelle, you're up. What's a primitive triple?
No.
What is one? 5, 4, 15,
Yeah. 3, 4, 5.
3, 4, 5, 8, 15, 17.
Yeah.
So anything that's scaled down all the way.
Yeah.
Right. There are no common factors across the 3
Across the 3.
members of the triple. Or across the 3, I don't know, ton. Did you call them triplets? Across the 3 triplets, there are no common factors.
But you also said something about 15. Something about the.
Right? Like, isn't that what you were calling them? Like the 3 little? I don't know. Okay.
3 and not 4.
See you guys in a couple of weeks.
All
Have
right,
a
thank
great-
you. Thank you, Nantucket. Thank you, Sarah.
Bye, everyone.
Bye.
I don't know why I took